Hey there to our 212 subscribers, our future subscribers, and all the people that secretly watch us without subscribing. Today is New Year's Eve, and I hope you guys have an amazing and safe New Year's. We're going into 2026, and it seems unbelievable. Today's video, I've always been fascinated by the word quantum, and I don't know why, ever since I was a little kid. And so yesterday I decided to research what quantum physics really is. And it's, ironic because I was never into science at all. But for some reason the word just fascinates me. So 2025 has been named the International Year of Quantum Science and Technology. That does not mean everybody suddenly understands quantum physics. It just means the science world is recognizing how much our modern technology depends on discoveries made at the smallest scales, even if we still argue about what they really mean. So, what exactly is quantum technology in a way that most people can understand? Quantum is the behavior of the smallest divisible unit of a larger thing. A photon of light cannot be divided in two. So the quantum is the behavior of that photon. An analogy on a larger scale, so it's easier to understand, would be language. A letter is the smallest unit of a written language. If you cut a letter in half, it stops being a letter. So the quantum of language would be the behavior of that single letter. Hopefully that makes sense. It took me a while to figure that out. But quantum behavior looks different from the behavior of everyday objects because a single quantum unit acts in discrete, tiny steps that are not smooth, continuous, or visible to the naked eye. When many quantum units act together, the behavior averages out, creating the smooth, predictable results we see in daily life. An analogy, for those of you that want to understand it better, an analogy would be if you zoom in really close on a digital picture, you can see the individual pixels up close. The image looks blocky and jagged, but when you zoom back out, all the pixels blend together, and it appears smooth. Superposition means a single quantum unit can exist in multiple possibilities at once until it interacts or is observed. And so for the analogy on this one, I'm going to use a very quickly thrown together little thing here that I did. And it's very poorly done because, like I said, it's 7 a.m. and I'm only half awake. But so imagine this is like one of those signs that say stop and slow, right? So I don't remember how many years ago they were working on Main Street in El Tourist. And I came up to the intersection where the blinking light is. For those that don't know, this town has one traffic light and it doesn't change, it just blinks all the time. So it's where basically two highways come together and merge into one, if that makes sense. So anyway, there's this girl standing there, and I'm pulling up, and she's got one of those signs that say stop and slow, and she's going like this. Oh my gosh, I didn't try this out first. She's going like this, right? And I'm just like going, okay, so do I stop or do I slow, right? So this particular theory means that while she's doing this, the sign is stop and slow. Until she stops it, it is not a single thing. So when she stops it, it becomes a slow sign. That's the basics that best I can explain it to the best of my ability, because I was very confused by this whole thing. But scientifically, a single photon traveling through two paths, like a fork in the road, can take both paths at the same time. It's only when we measure or detect it that it chooses one path. Superposition seems theoretical because we cannot know the state of a quantum unit until we observe it. Theory predicts the probabilities of the possible outcomes. I really had a hard time.
The probability of an event happening is obtained by dividing the number of outcomes of an event by the total number of possible outcomes or sample space. This is from qmath.com.
I was not talking to my tablet. Sorry about that. Totally lost my train of thought now. Where was I? Okay. Anyway, the next section is quantum entanglement, and it's the idea that two particles prepared together show matching results when they're measured, even when they're far apart. Some scientists interpret this as one measurement affecting the other. I don't personally buy that explanation. I think the results were probably determined from the start. So if you're confused by this, don't worry, Einstein was too. What is proven is the correlation, not the cause. So even though we can't always see or predict quantum behavior directly, these discoveries form the foundation for the technologies that matter today. The United Nations declared 2025 the International Year of Quantum Science and Technology, also known as IYQ 2025, to highlight the global importance of quantum research and its impact on society. The intent was to celebrate 100 years of scientific progress since developing the matrix and wave mechanics. Over the last several decades, discoveries in quantum physics have led to breakthroughs in computing, communications, sensing, and materials. 2025 is a year to celebrate these achievements, encourage collaborations, and inspire the next generation of scientists and engineers. So let's take a look at how people celebrated throughout the year. The year kicked off at UNESCO in Paris with talks, exhibitions, and performances celebrating quantum science worldwide. A week later in Geneva, scientists and educators highlighted global collaborations in quantum research. Throughout 2025, international, I don't even know how to pronounce this, colloquia discussed the role of quantum science in science and technology. Late May brought a week-long celebration across Italy and Brazil on the history and impact of quantum science. In India, researchers gathered in Bengaluru to share the latest breakthroughs and connect globally. In the Philippines, a conference focused on regional quantum research and collaboration. Accra hosted events emphasizing quantum education and skills development. December's global event highlighted quantum science's role in sustainability and future tech. Barcelona welcomed students and educators to explore quantum science hands-on. Across the U.S., workshops engaged students and teachers in interactive quantum activities. Immersive programs introduced high schoolers to quantum concepts in fun, practical ways. Interactive displays visualized quantum principles for the public. Traveling exhibits in India showed VR, hands-on experiments, and public engagement. Japan combined music, visuals, and science to make quantum fun and understandable. In March, science performances and demos brought quantum concepts to life. Finally, the Nobel Prize recognized groundbreaking quantum research shaping next-gen technology. So, hopefully, you found this video interesting. I know I find the topic interesting but confusing. So if you're confused, I'm sorry. I'm confused too. But anyway, I hope that you enjoyed the video anyway. Please like, subscribe, comment, and share. And get your friends to do the same thing. And thank you so much for sticking with me through these years and getting me to this point. I will be back soon. Thanks.